Okay, so you saw the finale of Stranger Things with that massive, terrifying rift tearing through reality. But it makes you wonder, could something like that, or real wormhole, actually exist in our universe? To get it, we've got to start with Einstein and his theory of general relativity. His equations first predicted black holes, and then a weird theoretical bridge through spacetime. And get this, wormholes pop out of the very same math that makes your phone's GPS work. But then, in 1962, physicists found a huge problem. These things are just totally unstable. They collapse almost instantly. We're talking a fraction of a second, so tiny it's mind-boggling. You couldn't even get a single photon through before it snaps shut. So, useless for travel. They're basically a mathematical quirk that can't exist in reality. Or can they? In 1988, physicist Kip Thorne asked a totally different question, and it changed the whole game. The key to propping one open? Something straight out of sci-fi. Exotic matter. See, normal matter pulls things together. That's gravity. This stuff would push them apart. Now, negative energy sounds like total nonsense, right? Except it's not. We've seen it. It's called the Casimir effect, and it proves that negative energy is real, thanks to quantum mechanics. But here's the catch. The effect is tiny, microscopic, and unbelievably weak on its own. You'd need the negative energy equivalent of Jupiter just to hold open a 1-meter doorway. Okay, so let's say you had all that exotic matter. How would you even build one? Well, if you could, you wouldn't just be building a tunnel. You'd also be building a time machine. And that brings up all kinds of problems with cause and effect, like the famous grandfather paradox. Some physicists, like Stephen Hawking, figured the universe must have laws to stop this from happening. So, where are we with all this? Let's quickly break down what we know versus what's still unknown. And the research is getting even weirder, now connecting wormholes to quantum entanglement. What if every pair of entangled particles is actually connected by a microscopic wormhole? The biggest hurdle is energy. We need 1,000,000 times more power than our biggest particle accelerator. So physics doesn't say they're impossible, just insanely hard to make. Is the universe daring us?